Everybody, welcome back to the video. So today I wanted to talk about the potential for humans eventually settling Titan, but the depressing truth is that it's going to be completely impossible to even visit for thousands and millions of years. And the reason for this is just a fact of energy and thermodynamics. So in today's video, I'm going to be explaining all of the research, why, and then I'm going to be reacting to one video that's sort of spreading misinformation on YouTube about this. Okay, so if you haven't heard of Titan, it's basically the largest one of Saturn's moons, and it has a lot of really interesting characteristics that make it really unique in the solar system. So just some quick facts. First of all, it actually has an air pressure that's really similar to Earth at 1.45 bar. And this does make it so that you don't need a pressure suit to walk around on Titan. But the unfortunate thing is that the temperature is also minus 290 degrees Fahrenheit, which when you combine that with the increased pressure means that it's going to be producing a lot of heat loss when you're walking around on Titan. Now, the atmosphere is mostly made of nitrogen with a little bit of methane, and there's a noticeable lack of oxygen across the entire planet. Also, due to the thick atmosphere, you only have around 1 watt per meter squared of solar radiance, so that's about 1%, or no, sorry, 0.1% of what's on Earth. And then this does shield a lot of radiation, so you won't have to worry about radiation. Okay, finally, it's going to be really low gravity, and the only materials you're really going to find is methane, water, and hydrocarbons. So there's not going to be any silicon rocks or any metals or anything like that that you would probably need to have a settlement. Now, the most interesting thing about Titan is these methane lakes. So these are giant lakes that are sort of like oceans. They're actually bigger than the Great Lakes in the US. And you know, your initial thought is that you could be using this methane, which is what we call natural gas on Earth, for fuel. But we're going to be getting into why this isn't the case. So my research journey really started and ended with this paper, Energy Options for Future Humans on Titan. And this is by Amanda R. Hendricks. First off, she has a pretty positive opinion on Titan. And actually, her conclusions, which I disagree with, is that they could produce energy on Titan. So here she says, Saturn's moon Titan is the optimal location in the solar system for an off-Earth human settlement. So she's saying it's better than Mars even. And she says it has Earth-like qualities and a thick atmosphere that provides shielding from damaging radiation. Now, this is sort of a misconception about the radiation. So on Mars, the radiation is going to be much higher, maybe 100 times higher as far as background radiation compared to Earth. But it's still going to be 20 REMs per year or thereabouts. So what you're going to have is an increased risk of cancer, you know, maybe a couple percent increased risk of cancer per year. But you're not going to have a level of radiation where it's just going to be instantly killing people. Okay, and the same thing goes for space stations and the moon. Now, here's a sort of an interesting thing that she says here. She says, combustion of methane after electrolysis of the native water in combination with another source of power is a viable option, okay? But she also says something that contradicts this. She says, combustion of hydrocarbons alone is not efficient on Titan because it costs more energy to do the electrolysis needed to get the O2. So again, there's no O2, there's no oxygen in the atmosphere. And so to produce oxygen, you have to do electrolysis. Okay, if you can see here with the exact chemistry, it costs us 960 kilojoules per mole to produce the oxygen. And then when we burn it with either hydrogen or methane, we're not going to get as much energy back out. And that's before we actually include any inefficiencies in these systems. So when you do that, it's just completely impossible. Now here she says, in practice, a nuclear source could be used to run an electrolysis plant, while chemical energy is produced via combustion separately. Now, in my opinion, this logic doesn't really add up. So here you have, in this scenario, 90 joules of nuclear energy to produce the electrolysis, and then you're simply just going to get less power out by combusting the methane. And so you're basically just wasting 10 joules of the nuclear power that you could be using for other stuff. And the fact is, each one of these steps is going to be probably 50% efficient or worse, or maybe not that bad, but still, that's going to have major inefficiencies. And so you're really just wasting tons of power by doing this sort of chain of processing. Okay, now here's her second option. See, she says that hydrogenation of acetylene would be a viable option. And she shows that this would be an exothermic reaction here. So at least in theory, it could work. The problem is, there's almost zero acetylene in the atmosphere. And in fact, there's almost zero hydrogen in the atmosphere. Okay, so you're talking only 0.1% hydrogen in the atmosphere, probably because it's naturally going to react with the mostly nitrogen atmosphere, and then only trace levels of everything else, like including acetylene. So it's going to cost a lot of energy to extract this acetylene, especially when it's combined with all those other hydrocarbons. And I just don't see this being an efficient process. That's just my intuition, but I guess I would need to see more evidence that this could actually work. But my gut feeling is that this just would not work, and the efficiencies would maybe be, I don't know. Okay, so here she's justifying a way to produce hydrogen, and she says you could do pyrolysis of CH4 instead of extracting the hydrogen from the atmosphere. Again, this is going to cost energy to do, and then the problem is you still don't have enough acetylene to actually use the hydrogen. And again, yeah, more efficiency losses. It's just going to not work. Okay, and then her final option is to use nitrogen and hydrogen from the atmosphere and react them together. And once again, it's near trace levels of hydrogen in the atmosphere, and it's going to cost a lot of energy to extract this. And at the end of the day, when you include efficiencies, it's just not going to be able to produce net power. Okay, now here's a sort of interesting point. She gives the idea of using a greenhouse to produce oxygen. The problem that we'll get into later, and she even says it, is that you need to heat the greenhouse, which, a greenhouse, at least one of the surfaces would need to be made out of glass or something that's not very insulating. So you'll see why this wouldn't work, but basically the surrounding is 90 Kelvin, and so it's simply just going to cost way too much power to heat the greenhouse. Okay, and of course the second problem is there's only 0.1% of the Earth sunlight on the surface of Titan. So it's not even clear that plants would be able to survive. And then even genetically modified plants and algae, they simply would be producing barely any oxygen. And you would need to source the CO2 as well. Okay, now hydropower, I would argue, is the only one of these options presented in the paper that I think is actually viable. The problem is that it's kind of a chicken and egg situation where it's going to require an enormous amount of energy for even robots and especially for humans to actually produce a hydroelectric dam on the surface of Titan. And so I almost think you'd have to spend more energy to produce the dam than you would get out, especially when you factor in the need to bring materials to the surface of Titan and things like this. Okay, now in this paper, she mostly dismisses wind and geothermal. Basically, the wind is pretty calm on Titan, and also the geothermal activity is very low at the surface. Now, solar she actually puts forward as a viable solution, and I think it's sort of strange. So here she explains if you want to support the population of the US using the same amount of power that they use in the US, you would need a certain amount of solar panels, okay? And it's actually 10% of the surface of Titan, which already isn't possible. But the problem is there's no silicon or metal or anything that you could use to make solar panels with. And once again, it's only 0.1% of the Earth's power. So here she gives a really convoluted sort of scenario where you'd use the solar power to produce acetylene from methane and then go on that to do the process that we talked about earlier. And you're just running into the same issues as before. You just end up wasting more power than you get out of the process. Okay, so she concludes the paper by saying pretty much all of the energy solutions are pretty bad, but in her opinion, they would be viable on Titan. I'll disagree, but I'll be explaining why next. So here's just a kind of rough simulation I did of what you could expect to happen, even with pretty strong insulation, if you just wanted to build a simple house or base on the surface of Titan. So this is basically the equivalent of really strong housing insulation, and the surrounding is a dense atmosphere at 90 Kelvin. And you can see within a few minutes, your walls are going to be completely freezing, and within an hour, unless you have an immense amount of heating, you're going to be dead from just freezing to death. Probably within 30 minutes, actually. Okay, and here I had a ChatGPT run a little estimate for me. So in a 10 by 10 house and pretty standard, vacuum insulated conditions, it said, you need to use at least 5 to 10 kilowatts of power. And considering that there's not really a viable way to make power unless you somehow make hydroelectric dams, it just doesn't make sense. Again, even if you had a working hydroelectric dam, everyone on this planet would need to be using several, probably 10 kilowatts just to exist constantly. So the power of that dam would get used up pretty quickly, in my opinion. Okay, and again, you just run into some more practical problems. So when you land your spaceship on the surface of Titan, it's going to be made out of metal, which is a conductor, as you probably know. And so basically your entire ship is going to instantly freeze. And from that point on, you're going to need to be in a basically vacuum insulated spacesuit. Okay, and here's just one of another major problems is that Saturn is really far away and it has a big gravitational field. So it's going to cost you about 20,000 meters per second of delta V. And, on average, probably 5 years at least to get out there. And again, that's for all of your materials. So if you want to have solar panels, if you want to send anything with metal or silicon or anything, you're going to have a bunch of staged rockets, and it just doesn't make sense anytime in the near future. Okay, and this really brings us to what is the point of settling Titan, right? So you have options like Mars or space stations or places where it doesn't actually require much power to exist and it doesn't require much resources. And then you can also be harvesting resources at these different locations. On Titan, the only resources are, methane, volatiles like water, which you can find water across the entire solar system. And so the resources aren't very unique, and you're not able to transport them anywhere because you have to spend all that fuel to get off the surface of Titan. And again, there's no oxygen on the surface of Titan, so it's not like you could just replenish your fuel reserves like you could on a planet like Mars or Earth. Okay, now I really just need to react to some of these YouTube videos out here because basically they're all saying the same thing, and in my opinion, it's completely wrong. So I just searched, can we live on Titan? All these videos are basically the exact same thing, but I'm going to be reacting to this one, which has 1.2 million views. All right, so let's get right into it.
Due to uncontrolled greenhouse effects. However, even though the Moon and Mars may seem like relatively reasonable destinations, they also have fundamental problems. Neither of these planets are protected by a magnetic field or a significant atmosphere, which would force any future colonizers to live in underground shelters to protect themselves from deadly cosmic radiation. And just so you know,
okay, yeah, so just to jump in here, like we already discussed earlier, it's not necessarily deadly cosmic radiation. It's just going to slightly increase their cancer risk. And so it's perfectly fine to live above ground. They would just be better off living underground. And again, it's not like living underground is impossible. It's actually pretty easy. You just dig a hole and build a shelter. Okay, so on to the next clip.
However, Titan's abundant atmosphere also means that the air pressure is much more comfortable for human visitors. It's only 50% higher than that of Earth, which is perfectly manageable. So colonists could move on the surface without the need to wear uncomfortable pressurized suits. The dense atmosphere allows for much greater thermal exchange with the environment, so heated and super-insulated suits would be needed, along with, of course, an oxygen supply respirator, nothing that is not already within our reach.
Yeah, so that was a pretty good point, but I mean, like he's saying, you still need an oxygen supply, and you still need a heated suit, which actually is going to end up being just like the vacuum insulated suit that you need in space and Mars because of how cold it is on Titan and how dense it is. So really, I think the suit, it would be more comfortable since it doesn't have to be pressurized, but it's going to be probably the same size. Okay, so here he starts talking about nitrogen in plants.
So colonists would only need to add oxygen, using the existing nitrogen as a buffer to create breathable air. In fact, Titan's atmosphere is already composed of over 98% nitrogen, compared to our 78%, making it more similar to Earth's atmosphere than any other in the solar system. It's true there is no oxygen, but there are deposits of water ice located just below the Moon's surface. From there, one could easily obtain oxygen for breathing and for burning hydrocarbons. Colonists would need to live inside sealed structures.
Yeah, I mean, easy, that's kind of relative because you wouldn't have enough power to do the electrolysis. But yeah, you do have the H2O right there.
Solid and liquid hydrocarbons on the surface, Titan has all the fuel a colony could need. In fact, it contains hundreds of times more natural gas than all known reserves on Earth. Fortunately, in Titan's oxygen-free atmosphere, these liquids are not even flammable, making their conversion into fuel much easier.
Okay, so that's a misunderstanding there. So yeah, they do have more fuel than they could ever need, but the problem is they don't have any oxidizer, and so they couldn't actually use any of the fuel. As far as the fuel not being flammable, that's actually the problem, and it's not going to make it any easier to produce power.
There is so much nitrogen in Titan's atmosphere that we could use it as fertilizer just like we do here on Earth. Although Titan is inhospitable in itself, it seems to contain everything needed to build a completely self-sufficient colony, which would be vital given its great distance from Earth, 1.2 billion kilometers. Food production would be a critical challenge. Colonists would need to develop greenhouse cultivation systems that can operate in Titan's cold temperatures and use methane as a source of carbon for plants. Furthermore, cultivating resilient microorganisms that can convert local resources into food would be a...
Okay, so there made the point about fertilizer and nitrogen. You know, the fertilizer wouldn't really be the biggest mass that you need to bring anyway, so it's really not that important. And then we sort of discussed how it's just simply too cold for our plants to survive, and there's almost no light from the sun. So as far as making greenhouses and stuff, I think we already discussed that, it's just not possible. Okay, so to wrap it up, guys, unfortunately, it's just not possible to visit or live on Titan. And I really wish it was, because I think Titan is really cool. But anyway, let me know what you think in the comments. And of course, thanks for watching.